Morning. Welcome back. Hope you had a great weekend. It's time to get started again. We are starting a new unit. Unit 4 is about chemical reactions, so we'll be doing labs this week and next week. We'll have 20 labs to do. Please do your warm-up, element or compound. You'll just put a check in some of those boxes, depending on whether you think it's an element or a compound, whether it's organic or inorganic. And you have this in 6th and 7th grade, so hopefully you will remember it. The papers are in the boxes.
How was your weekend, Mr. Clark?
It was good, thank you.
Good morning, TJHS. Please stand for the U.S. flag.
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
The Texas pledge. Honor the Texas flag. I pledge allegiance to the Texas, one state under God, one indivisible. Please pause for a moment of silence.
We're going to be taking notes and doing some activities. We just make sure that they're following along and just point on one shoulder.
Okay.
Thank you.
2 people are missing.
Yes,
Thank you. Thank you. Okay, your warm-up, please. Stop talking and get it done. Okay, look at those chemical formula and tell me if it is an element or a compound. You learned this in 6th grade. And if you didn't learn it, well, you're going to have to relearn it. Yes, ma'am. O2, element or compound. Put a check in the box. Okay. Is it organic or is it inorganic? You have 2 checks for each one. Except like nothing more. You go to the restaurant and finish Okay, since some of you are not completing the activity, yes?
Rafael Martinez, sir.
No, he's not.
Is he?
No.
No?
No.
Okay.
Somebody remind me, Hanukkah, can you tell me what is an element versus a compound? What is different about them? I know the 6th grade was a long time ago. I know, but we got to remember this stuff. We'll be on their test. Ms. Miller?
It's like a compound is like more than one element.
Exactly. Okay, so when you think of compound, you have to remember it's going to be 2 different elements together. Okay? An element is just one element. Now there can be 2 of them and they can be stuck together, like O2. But O2 is still an element. Okay, so let's take a look at this. Okay, so for O2, how many types of elements are there?
1.
There's just 1, so it's an element. Now, from last year, Organic versus inorganic. Does anybody remember, in order to be organic, what does the compound have to contain? Carbon. Carbon and one other one. Does anybody remember? Yes. No. Carbon and hydrogen. There has to be carbon and hydrogen. Is there carbon and hydrogen and oxygen gas? No. So that would be inorganic. Okay? Water, H2O.
Yes.
Element or compound?
Compound.
That is a compound. And again, let me show you why. Because there are two different elements combined. Hydrogen and oxygen. They're different, therefore it's a compound. This one, there was only one, so it's an element. Okay. Is that water? Is it organic or inorganic?
Organic.
Is there carbon there?
No.
It's inorganic. There is no carbon. In order to be organic, it has to have carbon and hydrogen. Carbon and hydrogen. Okay. Table salt, sodium chloride, element or compound? Daniel. Element or compound? It is a compound. There's sodium and chlorine. Is it organic or inorganic, Jacob? It is inorganic. Okay. Aluminum, little Chris. Element or compound? It is an element. Very good. Armando, aluminum, is it organic or inorganic? Does it have carbon or hydrogen? Armando, aluminum, Al. It's inorganic. Very good. Bryn, this is a tricky one. Carbon dioxide, CO2. Is it an element or a compound? It is a compound. Is it organic or inorganic, Dalton? It is not. There's no hydrogen. Okay. You can't just think carbon. You have to think carbon and hydrogen. Or CH. There has to be a CH in it. Capital C and a capital H. Urea. Does anybody know what urea is?
No.
You all produce it. Urine. Yes. It is one of the chemicals that is in your urine. You go to number 1. Okay. Urea is CH4N2O. Is it an element or a compound? It is a compound. Is it organic or inorganic? It is organic because it has a C and an H. And it's also produced by living organisms like us. Okay. Any questions about that? Okay, go ahead and get your science journal out. We're going to add you'll need some glue. We're going to add a folder for your second 6 weeks warm-ups. Leave this later on your desk because we will be putting it in your new warm-up folder. We have some stuff to take care of in your journal.
We need a folder today.
You do not need the folder today. Okay, in your table of contents, the last thing we placed in your table of contents was the periodic table booklet, end of Unit 3. So we are beginning second 6 weeks on page 22. Everybody's going to get a piece of construction paper and you need to glue it down on page 22. Remember, when you glue this, everybody look up here for a second. Put glue here and here. Everybody look up here. I want to see everybody. Here and here. Okay? Tell Araceli that I still have her journal and I'm getting it caught up. And she will start it tomorrow. It will be done. Okay? It's been a lot of work for me to get it all in there. Okay, does everybody understand? Remember how to do this. If you don't like the color you get, you are welcome to switch with somebody. Yeah, that's on page 21. We should have glued that already. I'm going to see if you can get them out later. I'm going to check that a few of them in there at the end of the semester. Because I will check. So if you can't find any, don't worry about it. But I do a journal check at the end of the semester.
Yes, I do.
Okay, again, second 6 weeks warm-ups. Glue that down, page 22. And then label it second 6 weeks warm-up. While you're doing that, I'm going to hand out the Chemical Reactions Unit Organizer for our Unit 4. And then we'll go over that. This week, we're having lab tomorrow. So make sure you dress appropriately tomorrow. Girls, pull back your hair. No sandals. Make sure you have closed-toed shoes. We will be mixing chemicals tomorrow.
Is there going to be an eruption?
There may be. It won't be a large eruption, however. This can be glued down to page 23. Y'all need some more glue? Yeah.
What happened to the other one?
It died.
Oh, boy. Well, that's what happened to
Somebody traded pencil erasers.
What?
Yeah, you don't glue it flat. Like, how are you going to get anything in it? Throw that away. Get you another one.
How old was it?
Not very old.
Poor guy.
Should be here too. Freddie, do you have your drum with you? You left it here or you lost it?
It's right here.
Here it is. Okay, it's glued down. Yeah. That goes on page 23. Okay. All right. Ready to go. Here you go. Store it up. Do it there. You'll get one of those and roll down also. Okay, put this in here. Label it second 6 weeks warm-ups. Label that second 6 weeks warm-ups. Freddie, just pick it. You've gotten behind, just pick up, starting with page 22. And remember what we talked about last week. You try, you know the deal, okay? Stay on task and land. Get it moved down, doesn't take a minute. Okay, let's take a look at the unit organizer. Okay, unit organizer. This unit, Unit 4, is about chemistry. That thing right over there. It's now taking everything we learned about the atoms in the periodic table and seeing how the elements on the periodic table react to one another. Okay, we remember we talked about that they like to stick together because of the valence electrons. That's what this is about. It's chemistry. The atoms bonding together to create new substances. Okay? So chemical reactions is about understanding that new substances form when substances chemically change. So we are going to be creating some new substances that weren't there before. Now, in order to do this, we'll be describing what a chemical formula is. And we'll be looking again at elements, compounds, and molecules. You'll need to know the difference between those three things, and we'll be going over that. You'll need to know what a chemical formula is. We'll talk about understanding chemical bonding. We'll talk about ionic and covalent bonds. And bonding, again, is when the atoms do what?
Pretty good.
stick together. They want to stick together. We'll be looking at chemical equations. We'll be starting that today. You'll need to know the difference between what the reactants are and what the products are in a chemical equation. And then we'll be interpreting these chemical equations. You'll be looking for example, elements in a chemical equation, compounds in a chemical equation, and the stuff you start with, the stuff that's produced. We'll also be identifying evidence of chemical change. And you did some of that in 6th grade with Ms. Kiner. You looked at some of the stuff that can happen during a chemical change. And then finally, this is something completely new. You haven't had it before. We'll be describing what the law of conservation of mass is and looking at how that applies to chemical equations. Okay, our vocabulary for this unit: physical change, chemical reaction, chemical formula, chemical equation, product, reactant, subscript, coefficient, precipitate, law of conservation of mass. Some of these words get a little confusing, and we're going to go over them in a minute, and I'll show you the clue words. Okay? You'll have a vocabulary quiz next week. Okay, the unit questions, the questions you should be able to answer at the end of this unit. You need to be able to define what a chemical reaction is. You'll need to tell me what a chemical formula is. You'll need to be able to count the atoms in a chemical formula. And I think Ms. Thibodeau had y'all doing that at the end of last year a little bit. Okay, as a little precursor of what we're doing here. You'll need to know what a chemical equation is. You'll need to be able to identify the reactants and the products in a chemical equation. What are the 5 signs that indicate a chemical reaction has taken place? You'll need to know what the law of conservation of mass is. And then you'll need to be able to determine if the chemical equation is what is called balanced or not. And we have 2 weeks to learn all this. Okay, maybe a little longer. So we'll be taking our time. Tomorrow, as you can see already around the back counters, there are stations set up, and you and a partner will be working together. At the end of this class, I'll let you find the partner that you want to work with. And it's only going to be 2 people. If we have an odd number of people, somebody's going to have to work by themselves, because there's not enough room for more than 2 people to be at those stations. Everybody understand?
Yes, sir.
Okay, let's take a look at your vocabulary. Turn to the next page. You'll have to trim this and fold it just like we've done for all the other vocabulary. Again, trim the bottom. Remember, the red container is not a trash can. Lay it on the side of your desk, and I'll walk around and pick up the trash later. Lane, scissors, cut the paper. Okay, grab a highlighter. I'm going to show you the clue words. Help you remember your vocabulary. Some of the clue words are going to be more than one word in these definitions, because the definitions are a little complex. These words are a little bit more difficult than the words we've had so far this year. Okay, for the first one, physical change. Physical change states a type of change in which the form of matter is altered, but one substance is not transformed into another. Please highlight one substance is not transformed. One substance is not transformed. And not is the most important word there. A physical change, we do not get a new substance. Okay, we have just the same substance that's been altered. Can anybody give me an example of a physical change? Yes. Color? It's not really.
When you look down a
If you melt something, that's perfect. Exactly. If you melt something, that's physical. Because you still have the same, if you have a Crayola crayon, and you melt it, don't you still have a Crayola crayon? It's shaped this. What about this?
Still paper.
Still paper. Did it change? No. But its form changed, so it is a physical change. The tearing of paper.
There's something that's flattened.
Yes. We have a little on one of the days coming up, we are going to relearn all the physical and chemical changes. Okay, chemical change. Substances are altered into new substances. Altered new substance are the clue words there. Altered into new substance. And new substance is the most important thing there. New substance. Lane. What's the problem? Okay, stay focused. Chemical reaction. A change in which substances, this one you're just going to have to remember, is altered into one or more new substances. Chemical change and chemical reaction are almost the same thing. Usually on the vocabulary quiz, I will only give you one of them because it's almost the exact same thing. A chemical change is a chemical reaction. Okay? Chemical formula. Shorthand. Shorthand. It's a shorthand way to show a chemical substance. For example, instead of saying water, you can say H2O. Instead of hydrochloric acid, HCl. It's just a shorthand way of saying a chemical substance. Chemical equation, shorthand, and then chemical reaction. It's a shorthand way to show a chemical reaction. A whole reaction, not just one substance. Okay? Shorthand way for chemical reaction. Reactant, the one or more starting substances of chemical reaction. Highlight starting substance. Starting substance. Your reactants are your starting substances, stuff you begin with. Product, the one or more ending substances. Highlight ending substances. An ending substance. Subscript. Small number to the lower right. Small number to the lower right. So for example, for a subscript, which one of those numbers would be the subscript? The 2 is a subscript. The number to the lower right of the H. The coefficient, number written in front of a chemical formula. The number written in front of the chemical formula. Here, which one is the coefficient? The 3. Does anybody know what that 3 tells us here?
3 atoms.
Yes, well not 3 atoms, but 3 molecules. So you can write this, but this is equal to having 3 H2Os. Okay? That's what the coefficient tells you. How many molecules you have. Okay? Precipitant. Highlight solid form during chemical reaction. Solid form during a chemical reaction. So you might have 2 liquids. You mix them together and it becomes a solid. That solid that's produced is called a precipitant. You'll see that happen tomorrow during your lab. Most of the heavy metals will do that. Lithium, sodium, all of those. But they will also burn you, so you really can't do that. They're very dangerous. Law of conservation of mass. Mass of the reactants equals mass of products. Mass of reactants equals the mass of the products. Again, if you study a couple of those words each night until next week, you will have them all memorized.
Are they going to take the test?
I don't know yet. It just depends on how things progress this week. Okay, how things progress. Any questions about your vocabulary?
No, sir.
Okay. Okay, I have a demonstration for you. But in order to do the demonstration, you need a sheet. This will be glued down to the next page. And you can go ahead and glue it down now. Chemical reaction or not? I'm going to mix some chemicals over here, and then y'all are going to help me decide whether you think a chemical reaction has occurred or not. Okay, the first thing we're going to do, and I'm going to alter this a little bit, we're going to observe liquid A and solid A first, and then we're going to let you write down some descriptions. So, the first thing, yeah, you can glue it down. Go ahead and glue it down. And then we're going to do this together. There is a data table at the bottom, and you are going to be filling that out. I'm going to be bringing around the chemicals so that you can describe them. Okay, this is chemical number letter A, and in your data table it says, this word says bag A and liquid A. Okay, I'm not going to use a bag, I'm going to use a beaker, but somebody describe some of the white. Okay, that would be something good to write down. It's white. It's where it says bag A. Okay, it's sodium bicarbonate is what it's called. Okay. What else might you describe? It's a solid, white, powdery. Here, Lane walked it. Does it have an odor? Okay, does it have an odor? So you can't say it has an odor. Okay. So it's a white powder. It's solid. Where it says bag A, you should be writing this down. Where it says bag A. No odor. Okay. Here is liquid A. Liquid A. Somebody describe it. Yellow. Of course, it's liquid. Let's see if it has an odor. Walked it. Is it a strong odor? Walked it. It does have an odor. So I would want to walk it here. How would you describe it? Does it smell like urea? Is it urea?
Yes. Is it really? Oh, my
It looks like urea, doesn't it?
Yes.
No?
Anybody
else?
I'll walk it.
Still missing.
It does have an odor, so put odor. We'll find out in a moment. Okay. We're going to use the same powder for B, so go ahead and write the same description. And I'm going to put 5 scoops in here.
Wait, is it Pickles?
Here's liquid B. Well, it may be. It might not be.
Where would you get it? I mean, I can ask that question.
Okay, swap this one.
How do you know what a highlighter is? It's a highlighter.
Because whenever you because you had a highlighter.
No, it's when I highlight water.
No, I'm scared to smell it.
I don't want to smell it. I want to smell it.
I swear.
If it's vinegar, I will die. Hello. I hate vinegar. Oh, I know what it is.
No.
That's mixed with it.
It's not vinegar.
Smells like pickles.
What do you think it is?
Smells like vinegar. I don't think it's weird.
It's related to vinegar.
It's like vinegar juice. People just put vinegar on honey.
Okay.
Just not add vinegar.
It's something called acetic acid.
Oh, so I don't know.
It is a little caustic. It's related to vinegar. It's one of the vinegar-like substances, but it's acetic acid.
So it'll burn your
It isn't acid. It's not going to like dissolve your skin or anything. But it is possible. No, you can't touch it. Okay. The first thing we're going to do is I'm going to take substance A, which really didn't have much of a smell. But this one did. So do you think they're the same substances?
No.
Probably not. I'm going to measure out about 10 milliliters here. Maybe 20. Okay. I'm going to mix them and I want you to watch what happens. And then you're going to record what you see in the box where it says observations. Okay. Now, this and this white powder are what are called the reactants. What are reactants? The stuff you start with, the starting substances. Once I mix them together, if a chemical reaction occurs, we'll get something called products. Now, how are we going to know whether a chemical reaction occurs or not? There may be some sort of indicator. Okay.
It's
What else could we test it with to see if anything's happening? There were no bubbles. Did anybody see bubbles? No. What else might we be able to measure? Color. Did the color change? Not much. It's still yellow. Yeah, we can also check the temperature. Now, what would we have needed to do to see if there was a temperature change? We would have needed to measure it before we mixed it. Okay, but we could measure it before and after to see if what? The temperature changed. If the temperature changes, would that indicate a chemical reaction? It probably would.
Vinegar and baking sodas get colder or hot?
They get cold. Okay. And you'll see one that gets hot tomorrow. Okay. Again, I'm going to measure out. Did everybody write down their observations? Did you say that there was no visible change? No visible change, really, for that first one. Really no visible change. There were no bubbles, no anything. So let's see. Now remember, it's the same powder.
A different liquid.
And how did you know it was different?
Because it has odor.
It had an odor.
Smells like.
So in this one, again, we're going to see if anything happens. Acetic acid and sodium bicarbonate, when they're mixed together, you get
Well, it's weird though, it went up like real high and just went down.
what is causing the bubbles? What is? Okay, I know, but what would cause bubbles to form? Why bubbles? Why bubbles? I know you've done this since 3rd grade probably, because my 3rd grader just did it in Miss Ruther's class.
Because it has carbon.
What would make the bubbles? Nobody's probably ever explained that to you. Why bubbles?
It's reacting to the other chemicals.
Okay, but what form of the bubbles? Why? Okay, everybody's going to learn something today, definitely. Okay, when you mix sodium bicarbonate and acetic acid, a gas is produced. It is not. It's carbon dioxide. And when that carbon dioxide gets produced, it starts going up into the air. And as it goes up, it carries along with it bubbles. This is a very simple experiment you've done forever. Sodium bicarbonate is also known as baking soda. Acetic acid is a type of vinegar. It's a type of vinegar. It's a little bit stronger than normal vinegar. But when you mix those two, everybody write in your box, you get visible changes in the form of bubbles. Bubbles are produced. Also, feel the bottom of this glass, Daniel. Feel the bottom of that glass. What would you describe it? It gets very cold.
Temperature change.
There is definitely a temperature change. Okay?
This is for your goggles built in.
They're supposed to be done. Ready? Touch the bottom. It's really cold. So what 2 pieces of evidence did you see during this reaction? Bubbles and temperature change. Okay? Walked it. It's not nearly as strong as it was. Walked it. Did you smell it? Is it nearly as strong though? No. Because guess what? That liquid in there now is no longer acetic acid. It turns into something new. Guess what it is? That liquid in there no longer acetic acid. It's water. You create water. If you filtered it, you could take acetic acid and you can make water out of it by putting sodium bicarbonate. And tell me if it's nearly as strong as it was to smell. No, because it's no longer acetic acid. We have a completely new substance. Can't smell it, can you? Okay, let's look at the chemical equations on the other side of your page there. Okay, bag B, beaker B, which was this one right here. Is that the one that showed evidence? Yes, it is. Here's the chemical equation for this, and it's on your sheet up at the top where it says bag B. Please follow along. We're going to label some of these parts. Now, in this equation, this right here, is this an element or a compound? That's a compound. What about this one? So we took this, which is the sodium bicarbonate, and we added to it the acetic acid. This is the acetic acid. It produced carbon dioxide. That's what caused the bubbles. And water. And This is a new substance completely also. It's sodium, I have to look, it's written down here. Let me see. I can't remember what it's called. But it's no longer sodium bicarbonate. Okay? Please put a box around those and call them the reactants. Put a box around those and call them the reactants. These are our two starting substances. The sodium bicarbonate and the acetic acid. Okay? And again, what's that whole thing called? Chemical equation. You have to think of the arrow as an equal sign. Okay? Because when you mix these two together, they're going to equal this. So that's how it becomes an equation, because you have to think of it with plus signs and equal signs, and it's an equation. Okay, circle or box that side. Everything on that side of the arrow is called a product. And those are the things that were produced. Okay. Those are the products. And of course, those are all new substances. All of them are new. So we took two substances, mixed them together, and got three completely new substances. That's what a chemical reaction is. Okay. Now look at the formula at the top. On A, the top of your sheet. Did anything change there? No. So is that a chemical reaction? No. It's not. Okay. Bag A again. Sodium bicarbonate. That other thing was water with a little food coloring added to it to make it look like acetic acid. So it's just water with a little food coloring. When you mix those two together, you just get the same thing. There is no chemical reaction in bag A. Okay, let's take a look at again, those are the reactants, and those are still the reactants. There are no products in bag A. They're both still just the reactants. Okay? And they are not. There was no chemical reaction there. No chemical reaction. Okay, so again, this is the same thing. We've already labeled the reactants and the products. Now the thing that we need to add yet, these 5 things are called the chemical formula. So circle those and label them the formula. And then circle the arrow and write the word yields, because that's how you read it. So NaHCO3 plus HC2H3O2 yields CO2 plus H2O plus NaC2H3O2 is how you would read that. Or if you do the names of the substances, you could say sodium bicarbonate plus acetic acid yields carbon dioxide plus water plus sodium something. I can't remember the name of it. Sodium chloride? It's not sodium chloride. It's sodium. It's not. It might be written here. I'll have to look it up. I don't remember. Okay. Were there any elements produced?
Yes.
That's a compound, it's not an element. No elements produced. They were all compounds. Were there any organic compounds produced?
Yes.
Which one?
The one that
It is not, because it has sodium in it.
What?
Yeah. This one's not either. No, this one would be. This one's not, because it has a metal in it. And I don't know if Ms. Thibodeau taught you all that or not, but we will go over that again. Inorganic and organic. This one would be organic because it's just carbons and hydrogens and oxygens. If there's ever a metal in there, then it's not organic. Okay, it's not organic. Okay, questions? What is the difference in the two equations? In bag A, there were reactants and products are the same. For bag B, they were different. In other words, in bag B, there were new substances. Did a chemical reaction take place in bag A? No. Because the reactants and products are the same. Did a chemical reaction take place in bag B? Yes. How do you know? Because we had new substances. How do the reactants and the products differ in equation A? They don't. And in bag B, they are different. That means that there are chemical reactions that took place. They are different substances. The thing you need to realize from this whole little demonstration is that in order for a chemical reaction to occur, you have to have some sign that it happened, some evidence. And in this one, we saw bubbles, the temperature changed, and the odor changed. It wasn't as strong. And we also, by looking at the chemical formula, you could see that there were new substances formed. There were new substances formed. Here's your homework. I'm going to do one of these with you, and then you will do the rest. And remember, tomorrow, dress appropriately. There are stronger chemicals tomorrow than the ones I used in the demonstration today. Calcium chloride can burn your skin. No, you won't be getting it on your skin. Okay, let's get one of these homeworks together. Everybody get that? Okay, first we're going to go take a look at the lab for tomorrow. There's 4 stations that you'll go to. Station number 1 will have a thermometer. Guess what you're going to have to do? You're going to measure temperature change. You'll measure temperature change at every one of them. There'll be 2 liquids. You'll follow the instructions. There'll be a card at each station. You'll use one of the test tubes. You'll put 20 drops of one substance in. You'll take its temperature, then you're going to put 20 drops of another liquid in. You're going to take its temperature. You're going to look and see what has happened. On station 2, you will have a powder substance and a liquid. There is a stir rod, so what you're going to do is you're going to add the liquid. You're going to take the liquid's temperature. Then you're going to add the powder. 2 scoops, and there'll be a little scoop there for you to do that. And then there's a stir rod for you to stir. And you'll measure the temperature, you'll look for bubbles, you'll look for any kind of other changes that might be happening. On station 3, you will have another powder. It's calcium chloride, which can be a little dangerous, and another liquid. Again, you're going to add the liquid to the test tube. You're going to take its temperature. You're then going to add the calcium chloride, 2 scoops, and you'll observe any changes that happen. Station 4, there's going to be 2 liquids. You'll have to measure them using the graduated cylinder. You'll add one of them to a test tube. You'll take its temperature, then you'll add the other one and take its temperature, look for any observations that happen. And again, there'll be a card at each station where you can read to see what you're doing. Okay, on the homework, real quick, before the bell rings, let me do one of those with you. It's very simple. Let me pull it up on the screen here. It'll pull up real quick. If not, I'm just going to go over it. It says 4Al plus 3O2 yields 2Al2O3, and it wants to know what are the reactants in the products. Okay, number 1, 4Al. Is that a reactant or a product? No, it is a reactant. You always begin with the reactants. Plus 3O2, is that a reactant or a product? It is a reactant, and I don't know why this won't start. Oh, here it is. Except it's not on. Okay, the 2Al2O3 is the product. Oh, come on. And then you have to tell whether each of those is a compound or an element. 4Al, compound or element? Element. 3O2, compound or element? Element. 2Al2O3. Sorry, I couldn't get that to work.